Hi students, welcome to physics classes. Now I am very happy to announce I am starting IIT Foundation classes for 8th. Now here in our daily life we are doing many activities. In our daily life we are doing many activities that are writing, lifting the school bag, opening the door, closing the door, walking, like with our muscles we are doing many activities. In that all activities we are applying force. That all activities we are applying force. Now in IIT Foundation classes, first chapter we will discuss about force. 8th class, force. Now what is mean by force? Force is a push or pull. Push or pull on any object. On any object is known as force. Push or pull on any object is known as force. Opening the door, moving towards us is pull. Closing away from us is push. As this force has both magnitude and direction, both magnitude and direction, it is a vector quantity. It is a vector quantity. Now force F equal to mass into acceleration is the formula of force. F means force, M mass, M means mass, A acceleration. Now in coming topics we will discuss how this formula comes. Now SI unit of force, SI unit of force, SI unit or MKS unit, SI unit or MKS unit of force. Now how to write units? SI unit of mass into SI unit of acceleration. SI unit of mass into SI unit of acceleration. What is SI unit of mass? kg. What is SI unit of acceleration? Meter per second square. Kg meter per second square is the SI unit of force, and it is also written as Newton. To honor the scientist Newton, his name is kept as a unit of force, Newton, N, or while writing complete name we should use small. Scientist names writing as a units, if you write a symbol, capital N. If you write complete name, small m. Remember, while writing normal names we will use capital M. Normal names, first letter we will use capital. But while writing scientist names as a unit, we should write a small, complete name small, symbol capital. Okay. Now CGS unit. CGS unit of force. CGS unit of force, CGS unit of mass into CGS unit of acceleration. Gram centimeter per second square. It is also known as dyne. What is the relation between Newton and dyne? Or 1 Newton equal to dash dynes. 1 Newton means 1 kg meter per second square. So we should convert kg into grams, meter into centimeters, seconds always second. So 1 Newton equal to 1 kg meter per second square, that equal to 1 kg means 1000 grams into 1 meter means 100 centimeters by second square as it is. So 1, 2, 3, 4, 5, 10 power 5 gram centimeter per second square or 10 power 5 dynes. This is about force. Now SI unit of force we have taken Newton. What is the definition for Newton? What is the definition for Newton? 1 Newton. What is the definition for Newton? 1 Newton is the force acting on a body of mass 1 kg produces an acceleration of 1 meter per second square. 1 Newton is the force acts on a body of mass 1 kg. Acts on a body of mass 1 kg produces an acceleration of 1 meter per second square. 1 Newton is the force that acts on a body of mass 1 kg produces an acceleration of 1 meter per second square. Now, what are the effects of force? Now, when force is applied, what effects are taking place? What effects are taking place? Force changes or tends to change the shape of an object. Force changes. Force changes or try to change the shape and the size of an object. Whenever we apply force on dough, its shape will be changes. Whenever we apply force on the paper, its size will be changes. Whenever we apply force on the wall, its shape will not change. Its shape will not change. But whenever we apply force on the sponge, its shape will be changes. Whenever we tear the paper, size will be changes. Fold the paper, size will be changes. Next, force changes or try to change the state of a body. State means rest, motion. State means rest, motion. If the object is in the state of rest, if we apply force, it will come into motion. If the object is moving, if we apply force in opposite direction, opposite to the direction of motion, it comes to rest. It comes to rest. Next, force changes or try to change the direction of moving body. If a body is moving, whenever force is applied, its direction changes. For example, if you take cricket, when bowler bowls the ball, batsman hits it in some other direction. Whenever he apply force with the help of bat, direction of ball changes. Direction of ball changes. Even we can see volleyball, football. Whenever one player hits the ball in one direction, opponent player will hit the ball in opposite direction. So whenever he apply force, its direction is changes, no? So force changes the direction of moving body. Now next, force can changes or try to change the speed of moving body. Speed of moving body. Now whenever we apply force, if the ball is coming, let us take football. If a ball is rolling in this direction, if it is moving, if we apply force in the same direction, its speed increases. If we apply force in opposite direction, speed decreases. Speed increases, speed decreases. So change of speed, changing the speed of moving body. These are the effects of forces. Next, types of forces. Next topic, types of forces. We have two types of forces. First one is contact force. Second one is non-contact force. Contact force, non-contact force. Now we will discuss that detailedly. First one, contact force. Contact force. Contact force means, for example, here I am writing with pen. Force I am applying. So by touching or without touching? With touching. I am lifting the book. So with the muzzle I am lifting. With my hand I am lifting. Whenever I am lifting the book, am I touching or not? Touching. So Force applied with physical contact. Force applied with the help of physical contact is known as contact force. Force between two objects. Force acting between two objects that need physical contact. That need physical contact is known as contact force. Force between two objects that need physical contact between them, or force exerted between two objects with physical contact. Force exerted between two objects with physical contact is known as contact force. Is known as contact force. Now we have some examples for contact force. Muscular force. Muscular force. Muscular force means we can say it is also known as biological force. Force means force exerted with the help of muscles of our body. Force exerted with the help of muscles of our body. Now we have taken some examples: writing with the pen, holding the book, throwing the ball, catching the ball, hitting with bat, kicking the football, walking, whatever we are doing in our daily life, that all are with the help of our muscles is known as muscular force. Force applied with the muscles of our body is known as muscular force. Second one, frictional force. Second one is frictional force. The force which opposes the relative motion between two bodies. Force which opposes the relative motion between two bodies is known as frictional force. Is known as frictional force. Now, relative motion, opposing relative motion means, for example, one object, this is another object. Now, when it is moving in any one direction, when this object A moving on B in this direction, A is moving in this direction, A is moving in this direction. So between these two bodies, one force is there that acts in opposite to the direction of motion. Opposite to the direction of motion, that is frictional force. This try to oppose the motion between these two, relative motion between these two bodies. Whenever we applying force in this direction, frictional force is acting in opposite direction to oppose the motion of a body. To oppose the motion of a body. Frictional force is also known as resistive force or resistance force. Resistance or resistive force, which acting opposite to the direction of motion. Opposite to the direction of motion. For example, on the floor, if you throw the ball in one particular direction, after traveling some distance, it is getting stopped. After traveling some distance, it is getting stopped. Why that body is coming into rest? Why that body coming into rest? Some opposing force is there. Some opposing force is there, that is frictional force. That is frictional force. Next one is normal force. Normal reaction force. Simply we can say normal force or reaction force. Normal force or reaction force. Now normal force in the sense, for example, on the table if you kept a book. Now, book weight of the book is acting downward direction. Weight of the book is acting downward direction. To balance this weight is a force. Weight is a force. Book should come down, but it is not coming. So one opposing force applied by the table in on the book in opposite direction is known as normal force or normal reaction force. Normal or reaction force. Now, what is meant by normal force? Force that acting perpendicular to the surface of contact. Force acting perpendicular to the contact surface. perpendicular to the contact surface. Or can we say normal force is acting opposite to the direction of weight? No. In all cases, in this case it is okay, but in all cases it is not possible. Let us take one another case. For example, this is a wall. Now I kept a book here. Will it hold? No, it will fall. So to stop it, I am applying force. There is a wall. Here I kept a one book. To stop without falling, I applied force like this with my hands. So force is applying like this. Now what is the direction of weight? This is the direction of weight. Weight is always towards the center of earth. Weight is always towards the center of earth. So weight is acting downward direction. Weight is acting downward direction. What is the direction of normal force? This wall is applying, which is opposite to the direction of force. This is normal reaction. It is normal reaction. In this case, these two are not opposite direction. Normal force and weight are not in opposite direction, perpendicular direction. Sometimes it is perpendicular. Now some different cases we'll take. Now when an object is placed on inclined plane, inclined like this. Now weight is acting downward direction. Normal force like this will act. So in different cases it is acting differently, but all cases it is acting perpendicular to the contact surface. Perpendicular to the contact surface. This is normal force. Now an object is kept on the table, you said, sir. Now suppose if I take an object tied with the help of string and connected to the ceiling, fixed. Now here normal force is there. In this case, the force is tension force. Tension force. So as like here normal force, a book is placed on the table, weight is coming down, acting down to oppose its weight, table is applying opposite force, that is normal reaction. Here weight of the body is acting downward direction. To balance it without falling, string is applying some opposite force, that is tension force. The force which applied towards the string, force applied towards the string is known as tension force. Or we can say force applied by string on a body when the body suspended by string with fixed support. Force applied by the string on the body when it is suspended by the string is known as tension force. Next, non-contact forces. Non-contact forces. Non-contact forces means force acting between two objects without physical contact. Force acting between two objects without physical contact. Force acting between two objects without any physical contact. Without any physical contact is known as non-contact force. Is known as non-contact force. Examples for non-contact force: gravitational force. Gravitational force is the force acting between any two objects in the universe. An attracting force. Gravitational force is an attracting force that acting between any two objects in the universe. Now if it is on the earth, we will say it is gravity. Force of gravity we will say. So force of gravity means force acting between earth and any object on the surface of earth. Force between earth and any object on the surface of earth is Force of gravity. Gravitational force in the sense any two objects in the universe. Force, attracting force between any two objects in the universe. Like between two planets and a satellite, like any two. That is gravitational force. Without touching, it will attract. Without touching, it will attract. For example, if I leave this pen, it is falling onto the book, means moving towards the earth. So earth is applying force on this every object. Earth is applying force on every object without touch, without physical contact. That is known as gravitational force or force of gravity. Next, magnetic force. Next one is magnetic force. Force between two magnets, either attracting force or repulsing force. Force between two magnets or between magnet and magnetic materials. Magnetic materials like iron, nickel, cobalt, magnet and magnetic materials. Force between magnet and magnetic materials or between two magnets. Between two magnets, the force is known as magnetic force. If you kept two magnets, uh, north to south, another magnet also north to south, gap is there between them, gap is there, but these magnets both can attract, no? Or else if you kept an iron nail here, that will be attracted by the magnet, that will be attracted by the magnet. That is magnetic force. Next one is electrostatic force. Now, like magnetic force, electrostatic force is also attracting or repulsive force between two charged bodies or one charged body and uncharged body is electrostatic force. Electrostatic force. Now, this non-contact force is also known as field force. Non-contact force is also known as field force or force at a distance. Force at a distance. Non-contact force is also known as field force and force at a distance. This is about non-contact force. Now we'll discuss some objective type questions related to the topics what we discussed. What we discussed? We have discussed about force and the formula for force, units of force, relation between SI units and CGS units of force. And we discussed about definition of force, effects of force, and the types of forces. In types of forces, contact force, muscular force, frictional force, normal reaction, and tension force. In non-contact force, we discussed about gravitational force, magnetic force, and electrostatic force. Now we'll discuss some objective type questions related to the topics what we discussed. Now the first question is, the force always attracts the object towards earth is called. The force always attracts the object towards earth is called. Which force? Gravitational force. It is gravitational force. Now next question is, the force which acts between two magnets. Force which acts between two magnets is called. Now what? Magnetic force. Magnetic force. Next question, the force that can pull small objects of iron. Force that can pull small objects of iron is called what? Magnetic force. Next question, which of the following is force at a distance? Force at a distance means non-contact force. Force at a distance means non-contact force. Now which of the following is a non-contact force? Magnetic force. What are the non-contact forces? Magnetic force, gravitational force, electrostatic force. Now what is normal force? Contact force. Frictional force, contact force. Tension force, contact force. Next, force exerted by muscles of our body. Force exerted by muscles of our body. What? Muscular force. Force exerted by the muscles of our body is known as muscular force. Next, force acting perpendicular to the contact. Force acting perpendicular to the contact. Same options. What? Normal force. Force acting by the string to oppose weight of the body. Force acting by the string. Same options. Tension. Force that opposes relative motion. Opposes relative motion between two bodies. Same options. Frictional force. Frictional force. Next question. Which of the following is contact force? Which of the following is contact force? Gravitational force, gravity, non-contact force. Magnetic force, non-contact force. Frictional force, contact force. Electrostatic, non-contact force. Next, SI unit of force is. SI unit of force is. SI unit Newton and kg meter per second square. We can write kg meter per second square like this also, by square coming up inverse square. CGS unit of force is what? Dyne gram centimeter per second square. 1 Newton equal to dash dynes, 10 power 5 dynes. Next, 1 dyne equal to dash newtons. 1 dyne equal to dash newtons, 10 power minus 5 newtons. Next, gravitational force is option 1 only attractive, only repulsive, both attractive and repulsive. Gravitational force only attractive, it won't repel any object. Gravitational force is only attractive, it won't repel. Next, magnetic force is magnetic force, same options, both attractive and repulse. If another one is magnet, opposite poles attract, same poles repulsive. Magnet and magnetic materials attractive. Next, electrostatic force also both attractive and repulsive. Electrostatic force also both attractive and repulsive. Next question. What is the force acting on an object of mass 5 kg moving with 2 meter per second square? So mass equal to 5 kg, acceleration is 2 meter per second square, force equal to mass into acceleration. So force equal to 5 into 2, 10. What is the unit? 10 we got. In third option, fourth option, both 10 are there. So which one we can keep? Newton. Force units Newton, not kg. So this option. Next, calculate the acceleration produced by a body of mass 3 kg acted upon by force 18 newtons. Same formula. F equal to mass into acceleration. We should find acceleration. Force by mass, force 18 newtons, mass 3. So cancel 6, 6, 6, 6, 6. Acceleration units meter per second square. Next, force is a scalar quantity or vector quantity. Force is a vector quantity. Why force is a vector quantity? Because it has both magnitude and direction. Both magnitude and direction. So it is a vector quantity. Next, calculate the force required to move a body of mass 6 kg with an acceleration 6 meter per second square. Force equal to mass into acceleration. So mass is 6, acceleration also 6, 36. What is the unit? Newton, 36 newtons. So first synopsis and first worksheet of force we discussed now. In the next class, we will discuss remaining topics related to force chapter. Thank you for watching. Please subscribe for more updates.